Alright, my name is Sadiq, and we're here to do the AC circuit.
My name is Jackson.
Alright, first thing we're going to do is build our AC circuit in Multisim. So I have Multisim open right here. First thing first, we're going to place our title block. I'm going to choose the default. Place it right here. I already have it set up. AC Team Video, designed by Sadiq and Jackson. Alright, now let's go ahead and bring in our AC power supply. Go ahead and put that there. And then our analog ground, place that there. And let's bring in our resistors. So the first one we'll bring in is a 1.5 kilo ohm resistor. Leave that there. And then a 6.8 kilo ohm resistor as well. I'll put that there. And we'll go ahead and rotate it. Now we can go ahead and connect these up. So those are in series. Put R1 in series with R2. And then go ahead and there, and then we'll move the ground a little over here. And there we go. And let's go ahead and change the color of the ground to a different color. Alright. Now let's bring in our voltmeters. And we're going to bring in a vertical voltmeter for both the input voltage and R2. And actually, before we do that, let's go ahead and change the values of our input voltage. And we're going to change that to 3.53. And that's going to be in volts RMS. And then our frequency, we'll change that to 700 Hertz. And we'll go ahead and call this V in. And then for a voltmeter, we'll change this to AC. And we'll call this V in underscore RMS. And then we can connect this up. And the negative goes to negative right here. Move this out of the way. Perfect. And then the voltmeter for resistor 2, we'll call it V2 underscore RMS. And we'll change that to AC. And we'll also connect that right here in series. Or sorry, in parallel. And move this up here out of the way. Alright, and then let's bring in an oscilloscope. Oops, right there. And we'll go ahead and connect channel A to our input voltage. And this goes to negative here. And then channel B will go to R2. And we'll go ahead and change this color to a different color so we can tell the difference. Alright, and now we can go ahead and run it and get some data. And as you can see, our input voltage RMS is 3.535 volts RMS, and across R2 we have 2.896 volts RMS. So we'll go ahead and stop that, and now we'll open up our oscilloscope. Let's expand this out a little bit if it wants to cooperate with me. There we go. And then we'll reverse it so we can see a little better. And we'll hit play to get a little bit more data. We'll stop it right there. Let's bring it towards the middle. And first we want to look at our input voltage. So let's go ahead and turn off channel B. And then let's make our input voltage a little bigger, easier to see. I'll do right there. All right, so first we want to find our peak to peak for our input voltage. So we'll drag our cursor right here. So we'll right click and we'll go to next. Oops, bring that out. Go to next Y min right there. For this one, we'll go to next Y max. So our input voltage peak to peak is going to be 9.983 volts peak to peak. And then we want to look at our period. We'll bring cursor 1 over here. Then right click, we'll go set the next Y value to 0. And that's the beginning of one cycle. And then our second cursor will set our Y value to 0, which is the end of one cycle right over here. And you see we have 1.429 millisecond. And and that's the period right there. And in order to find the frequency, we're going to have to bring in a calculator. And I just have one Google right here. And we have 1 divided by 1.429. And since it's milliseconds, we're going to do exponents to -3. And we have 699 hertz, which is very close to that 700 right there. All right, so next, let's look at our R2. So we'll go ahead and turn off channel A and turn on channel B. And let's make this a little bigger. We'll go one right there, that should be good. And then first, let's look at our V2 peak to peak. And we'll put our cursor 2 right here. And we'll go to next Y max. And our cursor 1. Go to our next Y min. And our V2 peak to peak is 8.178 volts peak to peak. And then if we want to look for our period, we'll put cursor 1 over here at the start of the cycle, and we'll go to set next Y value 0. And at the end of the cycle, we'll drag cursor 2 and then set Y value to 0. And again, you get 1.429 milliseconds, and which is our period. And then here's the formula: 1 divided by 1.429 milliseconds, which is 10 to the -3, and you get 699 hertz, which is the frequency.
First, measuring the resistance of each resistor. Alright, so the first resistor is 1.51 kilo ohms.
Yeah, you pull up the report, exactly.
Next resistor is 6.7 kilo ohms.
And both of those are within tolerance of their color bands.
Alright, you pull up something and it's saying, I didn't look, I thought I was like 12.
Alright, so the first thing we're going to do is we're going to take 10 and then divide that by 2. And then multiply by 0.707, which gives us the RMS. And then connect function generator.
So that's what finds the VP.
you know what it's
Red
saying?
to red,
Divisions, and then we're converting that to.
and then
So there's 2 volts per division.
black to black. And you change this to.
That's what he tell us.
Oh, I'm gonna change this to. Why is it not?
I think it's 20. The camera. The presentation.
Change it to AC. Volts.
If he tell us about it. I wish you guys good luck.
Also, if you're interested, you can also, like, you don't have to come out and look at it.
Really?
Yeah, Zoom.
Okay, that's good.
Yeah, so you could be in bed, you don't have to share.
Probably up, right? There we go.
So just click on the Zoom and then watching your presentation.
5.
There's 5 people presenting, 6.
6.
Yeah, it's 20 minutes each. It's long. It's gonna be 3 hours. Yeah, we're going minimum.
He said like 9 to 2.
Four.
Hopefully, we're going 4 till 2. You're going 4?
Yeah.
Oh yeah.
This thing is so fidgety. 3 point.
Oh, you guys doing
There was only one group who do design, which is
5. I think that might be close. Yeah, that's close enough. And then the frequency was set to 700 hertz.
Oh,
Good.
Alright, so now that we have our values, we're going to build our circuit. So this is R1 and this is R2. So we're going to put R1 in power and connect it into the breadboard. And then we're going to take R2 and put it in series with R1 into the ground. And now we're going to get our jumper cable, our jumper wires. And we put 1 in power and 1 in ground so that we can connect our function generator, which is already set to the correct values. And now our circuit is ready, and we need to connect our oscilloscope to measure. So we're gonna get our oscilloscope. We're going to put one side on the same area in multisim at the start of resistor 1, and then the other side will go on the into ground as it is in multisim. And now we turn all of our tools on. So now we have our channels, and we're going to use auto to get it set up for us. And now we have channel 1, so now we're going to use it to show the different values. So we're going to start off with voltage peak to peak. And we're going to adjust the scale so that it's the best for us. Move the position. And adjust it so that it's on a flat area. And now we're going to see channel 1, each division is set for 2 volts. So each square represents 2 volts. So then we count 1, 2, 3, 4, 5, and then 1 hash right there. So it's 5 and 1 hash, which means that we know to use our calculator, and we have 5 times 2 is equal to 10 volts, and then the 1 hash is going to be 1 times 2 volts divided by 5. So then we have 0.4, and so then we have 10 plus 0.4, and we have 10.4 volts. So that's how we get our peak-to-peak old school. Now we're going to move on to RMS. So we come back to the calculator. We know that our peak-to-peak is 10.4 volts. To find RMS, we find our peak by dividing it by 2, and then we multiply our peak by 707, and we get this. It's a little off just due to having to count the hash marks and not getting exact amounts, as well as the variancy in real life, but this is close enough to our RMS that we calculated for at the beginning for it to not be alarming. Now we're going to measure the period, so we're moving back to the oscilloscope. We look down here, we know that each division is 200 microseconds, so then we're going to choose a rising spot on the line, which we have. Did not mean to adjust the scale. So we take it, that part right there is at the start of our divisions, and we're going to this spot. So we count 1, 2, 3, 4, 5, 6, 7 divisions. And it doesn't appear to be at the hash, it appears to just get to 7 divisions. So then we're going to do 7 times 200 for 1400 microseconds, which we also know is 1.4 milliseconds. So we know that our period is 1.4 milliseconds roughly, and it's at 1400 microseconds. To find our frequency, we do 1 divided by so 1.4, and then second EE for our engineering value, and then -3, and we get 714.3 hertz, which is very close to the values that we have in Multisim. Now we're going to go back, and we've measured all the values old school. Now we're going to move on to new school. So we come over here and we get the measuring menu. The first value is peak to peak, which we get it, and we get 10.3, which we had 10.4 old school. Then we move on and we go back to voltage, and we scroll down. We have the RMS. We get that. It's 3.4, so it's a little lower, but that is our VRMS value. Now we go back to the measure menu, and we get period. Close the menu so that we can see it. Our period is 1.43 milliseconds, which is very close to what we had. And finally, we open up the menu one more time, and we get frequency. Close the menu, and we look, our frequency is at 700 hertz, which is very close to the value we calculated.
Alright, so I have the oscilloscope probe connected to V2. Then the first thing you do is turn off channel 1 and go to channel 2. And then to get the volts peak to peak, we just did, there's 4, 1, 2, 3, 4, and divided by the 2 volts right here, which gives you, or sorry, multiplied by the 2 volts here, which gives you 8 volts peak to peak, which is pretty similar to our Multisim. And then the next thing we did was we centered it, and then you have 1, 2, 3, 4, 5, 6, 7, and then you do
Between the 2 rising marks, there's 7 divisions.
yeah, from the start to the next start, and then you do 7 times the 200 microseconds, which gives us 1.4 milliseconds. And then to find the period, you just do 1 divided by, actually just 1 divided by the answer, and that gives you your hertz. Alright, And then to find the voltage RMS, you take 8, and then you divide that by 2, and then you multiply by 0.707, and there's our voltage RMS.
Which is the same as our multi-sim value as well. New school. New school.
Oh, new school. All right. To find everything new school, we just go to measure, and then we go to voltage, and then go to voltage peak to peak. And there's our voltage peak to peak, which is similar to what we got old school. And then we go voltage, and then VRMS, and there's our VRMS, which what we got old school was 2.8, so very similar. And then we go measure time, our period. So our period 1.43, about the same. And then time, last one is frequency, and 700 hertz.